I'm going to describe an earthquake fingerprint scanning technique that was created by students at Miami University. First, let's review how fingerprint scanning works. We begin with the template pattern that we are looking for in a large dataset. We compare the template to each recorded fingerprint and look for a case where the patterns match. Although many other fingerprints look similar at first glance, a computer can automate the analysis to tell us when the patterns do match and when they do not. A similar pattern comparison can be made for earthquake observations, where seismic wave recordings at a variety of sensors are used like fingerprints. Each set of wiggles represents the ground vibrations from a different earthquake observed by sensors in Ohio and Pennsylvania a few years ago. The blue event represents the first known earthquake in the Youngstown, Ohio area, occurring in early 2011 at about a magnitude of 2.6. To determine if other similar events took place, we created a template of this earthquake and scanned all available records for similar patterns. Our scan revealed hundreds of other earthquakes that were too small to be detected by traditional techniques. You can see how the black template wiggles match those of the green earthquake months later into the sequence. But the template does not match the red earthquake that occurred in a different part of Ohio, so our scanning technique is able to discern different earthquake fingerprints. To help reinforce why this technique is important, I've hidden all of the events we found to show how the original detection was limited to just less than a dozen earthquakes. But not only does our technique find hundreds of additional earthquakes, it shows how those events started and stopped within days of deep wastewater injection wells being turned on in December 2010 and off in December 2011.